This is 5.2, right triangle trigonometry, part 1. Today we're going to be looking at the different trig ratios with your right triangles. So these trig ratios, they're sine, cosine, tangent, cosecant, secant, cotangent. If you realize here, your sine is opposite over hypotenuse, your cosine is adjacent over hypotenuse, your tangent is opposite over adjacent. Your cosecant is literally the reciprocal of sine, so you just flip it. Your secant is the reciprocal of cosine, so you just flip cosine. And then your cotangent is the reciprocal of tangent. With these, you are going to pay attention to where your angle of measure is. So wherever theta is, that's where you're going to figure out where your opposite and your adjacent is. Your hypotenuse is always going to be the side length that's across from your right angle, which is your largest side length. So again, depending on where theta is, where that angle measurement is, you are going to be finding the opposite and the adjacent, or identifying the opposite and the adjacent side lengths. Some of these you're going to have to also find the missing side length. Remember, with a right triangle, to find the missing side length, you can use a squared plus b squared is equal to c squared. Your cosecant is that CSC. Your secant is this SEC, and then your cotangent is that COT. So if we look at this slide, it tells us that the symbols we use for these ratios are abbreviations of their full names. So sine is SIN, cosine is that COS, tangent is TAN. If you looked at the slide before this, so again, if we have to look at where that angle measurement is, or where theta is, your opposite is going to be across from it, your adjacent is going to be next to it, and then your hypotenuse is always across from your right angle. Same thing with that other triangle there. Your theta is on the bottom left-hand corner of that triangle, so opposite that right angle is your hypotenuse, opposite the theta is your opposite, and adjacent theta, or next to theta, is your adjacent. So if you were to take the sine of that smaller triangle with those side lengths of 3, 4, and 5, your sine would be opposite over adjacent, which is just 3 over, opposite over hypotenuse, which is just 3 over 5. Same thing with the larger triangle. Your opposite is 30, your hypotenuse is 50, so that's 30 over 50, which still simplifies to 3 over 5. If you look at example 1, it tells you to find the 6 trig functions of the angle theta. So think about it this way. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You know that the reciprocals of these are cosecant, so CSC is the reciprocal of sine. So that's hypotenuse over opposite. The reciprocal of cosine is secant, so that's hypotenuse over adjacent. And then your reciprocal of tangent is cotangent, which is adjacent over opposite. So if we look at our triangle, our theta is in that bottom left-hand corner. So the side length that's across from your right angle, that 3, is your hypotenuse. If we look at theta and we go across from your theta, that's our opposite. And next to theta is our adjacent. So if you want, you can identify all of these side lengths. So opposite is 2, adjacent is the square root of 5, and your hypotenuse is 3. So we just plug all of these in and simplify. Remember, you cannot leave a radical in the denominator, so you have to rationalize those denominators as well when you're doing these. So for sine, we have opposite over adjacent, so that's 2, opposite over hypotenuse, so that's 2 over 3. Cosine is adjacent over hypotenuse, so that's the square root of 5 over 3. Tangent is opposite over adjacent, so that's 2 over the square root of 5. You cannot leave that radical in the denominator, so multiply top and bottom by that radical. That gives us 2 square root 5 all over 5. For your reciprocal of sine, that's cosecant. So that's hypotenuse over opposite. So flip your fraction. That's 3 over 2. For your reciprocal of cosine, that's secant, S-E-C. Flip that fraction, so it's 3 over the square root of 5. Again, you cannot leave the radical in the denominator. So multiply top and bottom by the square root of 5. That gives us 3 square root 5 over 5. And then for the reciprocal of tangent, that's cotangent. So take the reciprocal of that. That's the square root of 5 over 2. So we have sine, that's 2/3. Cosine, that's the square root of 5 over 3. Tangent, that's 2 square root 5 over 5. Cosecant, that's 3 over 2. Secant, that's 3 square root 5 over 5. And cotangent, that's the square root of 5 over 2. If we look at our next set of examples, we're finding all 6 trig functions. Exact values only, no decimals. So remember, this is exactly what we said in the slide before this, but your sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. For example 1, we have a triangle that has side lengths of 5, 12, and 13. Your hypotenuse is across from that right angle, so that's 13. Your theta across from that is 5. That's your opposite. Next to it is your adjacent, which is 12. From here, plug in your values for sine, cosine, tangent, and then take the reciprocals of them. So sine opposite over hypotenuse is 5 over 13. Cosine adjacent over hypotenuse, so 12 over 13. Tangent opposite over adjacent, so 5 over 12. Cosecant, take the reciprocal of sine, that's 13 over 5. Secant, take the reciprocal of cosine, that's 13 over 12. And cotangent, take the reciprocal of tangent, that's 12 over 5. For number 2, we're given a triangle that has side lengths of 5 and 8. We are missing that side length that's across from our right angle. So that side length is our hypotenuse, that's our c in a squared plus b squared is equal to c squared. So if we do 5 squared plus 8 squared is equal to c squared. The 5 squared is 25. The 8 squared is 64. If we add the 25 and the 64, that gives us 89. So 89 is equal to c squared. We take the square root of both sides. With this, remember you're dealing with a distance, so you're not going to take the plus or minus of that square root. It's just going to be the square root of 89. So this x is really the square root of 89. Identify your hypotenuse, your opposite, and your adjacent. We said the hypotenuse is across from your right angle, so that square root of 89 is your hypotenuse. Theta across from that is 5. That is your opposite. Next to it is your adjacent, which is 8. So plug these values in and simplify. For sine, opposite over hypotenuse. That's 5 over the square root of 89. We multiply top and bottom by the square root of 89. To rationalize this, and we get 5 square root 89 all over 89 for sine. For cosine, adjacent over hypotenuse, that's 8 over the square root of 89. We multiply top and bottom by the square root of 89. So that gives us 8 square root 89 all over 89 for cosine. For tangent, that's opposite over adjacent. So 5 over 8. For our reciprocal functions, for reciprocal of sine, that's cosecant. So that's going to be the square root of 89 over 5. For the reciprocal of cosine, that's secant. Again, reciprocal of the 8 over the square root of 89. So that's the square root of 89 over 8. And the reciprocal of tangent is cotangent. So that's just 8 over 5. For example 3, we have a triangle that has side lengths of 4, the square root of 29, and x. That x is either your a or your b. So if you use it as your b, you're going to have 4 squared plus b squared is equal to the square root of 29 squared. That 4 squared is 16 plus b squared is equal to the square root of 29 squared is just 29. Subtract your 16 from each side. That 29 minus 16 gives you 13. So b squared is equal to 13. Take the square root of both sides. Again, just keep the positive. So b is the square root of 13. So that x is the square root of 13. Your hypotenuse is the square root of 29. Your opposite is the 4. Your adjacent is the square root of 13. Start plugging in your values for all of these. For sine, opposite over hypotenuse gives you 4 over the square root of 29. Multiply top and bottom by the square root of 29. That's 4 square root 29 all over 29. For cosine, again, adjacent over hypotenuse, so the square root of 13 over the square root of 29. Multiply top and bottom by the square root of 29. That gives us the square root of 13 times 29, which is 377 over 29. That square root of 377 is just the square root of 377. It does not simplify. So you cannot simplify that. That is in simplest form. Move on to your tangent. Tangent is opposite over adjacent. So that's 4 over the square root of 13. Multiply top and bottom by the square root of 13. And that gives you 4 square root 13 all over 13. Find the reciprocals of these now. Your reciprocal of sine is cosecant. So flip the 4 over the square root of 29. That's the square root of 29 over 4. The reciprocal of cosine is secant. That gives you the square root of 29 over the square root of 13. You multiply top and bottom by the square root of 13. And that's the square root of 377 over 13. And then find the reciprocal of tangent. That's cotangent. So that's the square root of 13 over 4. For example 4, we have a right triangle with side lengths of 8, the square root of 3, and x. So that 8 is your hypotenuse. So this is going to give you x squared plus the square root of 3 squared is equal to 8 squared. That's x squared plus 3 is equal to 64. Move the 3 over, subtract it from each side. You get x squared is equal to 61. Take the square root of both sides, and x is the square root of 61. So identify your adjacent and your opposite now. Opposite of theta is the square root of 3. Next to theta is that square root of 61. So now find all of your values: sine, cosine, tangent, cosecant, secant, and cotangent. For sine, that's opposite over hypotenuse, so the square root of 3 over 8. Cosine, adjacent over hypotenuse, so the square root of 61 over 8. Tangent, opposite over adjacent, so the square root of 3 over the square root of 61. Multiply top and bottom by the square root of 61. So 3 times 61 gives us the square root of 183 over 61. If we find the square root of that 183, you cannot simplify it, so it is exactly what you see there. The reciprocal of sine is cosecant, so that's CSC, and that means it's going to be 8 over the square root of 3. So we multiply top and bottom by the square root of 3, and that's 8 square root 3 over 3. Your secant is the reciprocal of cosine, so that's 8 over the square root of 61. So we multiply top and bottom by the square root of 61. And that's just 8 square root 61 over 61. And then the reciprocal of tangent is cotangent. So flip it, 60 square root of 61 over the square root of 3, which gives us, multiply top and bottom by the square root of 3. There we go. And that gives us the square root of 183 all over 3. If we look at our next set of examples, you are using a calculator in order to find specific values for your sine, cosine, tangent, cosecant, secant, and cotangent. Now, in your calculator, you have buttons for sine, cosine, and tangent. However, you do not have buttons for cosecant, secant, and cotangent. Because they are the reciprocals of sine, cosine, and tangent, you can do 1 divided by sine whatever to get your cosecant. To get your secant, you can do 1 divided by cosine whatever angle measurement. And then for cotangent, you can do 1 over tangent of whatever angle measurement. With these, when you are working with your 6 trig functions, you are working with the angle measurement in degrees, not radians. If you're working with them in radians, you have to switch your calculator to be in radians instead of in degrees. Normally, your calculators are automatically in degrees. So like I said, that's what you're working with in your calculator. Make sure what you're putting into your calculator is in degrees as well. If we look at these examples, we're just using a calculator to find the following and rounding to 4 decimal places. For example A, we have the tangent of 40 degrees. So again, it's in degrees, my calculator's in degrees. I can just hit the tangent button, then 40, close the parentheses and enter, and round that number to the 4th decimal place. If I do that, that's going to give me 0.8391. Next, we have the cosine of 20 degrees. So we put cosine, then 20, close your parentheses, round to the 4th decimal place. That's going to give you 0.9397. For example, C, we have the cotangent of 14 degrees. So there is no button in your calculator for cotangent. So you're going to have to do 1 divided by the tangent of 14, then close your parentheses. If you round that to the 4th decimal place, you have 4.0108. Next, we have the cosecant of 80 degrees. Cosecant is the inverse of sine. So we're going to do 1 divided by sine 80, close your parentheses, hit enter. If you round to the 4th decimal place, you get 1.0154. For your next example, you have the cosine of 52 degrees. That one, easy. Just hit the cosine button, 52, close your parentheses, hit enter. Round to the 4th decimal place, you get 0.6157. For the next one, you have cotangent of 78 degrees. Again, there's no cotangent button in your calculator, so you're going to do 1 divided by the tangent of 78. Round to the 4th decimal place, you get 0.2126. And lastly, you have the secant of 34 degrees. Secant is the inverse of cosine, so we're going to do 1 divided by cosine 34. Close your parentheses, hit enter. You get 1.2062.